Hi everybody, we will do Ohm's law, and this circuit is consisting of resistance, power supply, DC power supply, a voltmeter, ammeter, and some banana cables. As you can see, we will use three different resistors with three different values. We will start with this resistance right now. So what we will do, we will connect the circuit that I showed you, and then we will start the power supply and then monitor the voltage and the current and write them down. So let's get started. I will start with very low voltage and then increase it with steps. So let's do that. First thing, I will connect this banana cables with this positive point right here. So this is the negative point and this is the positive point of this power supply. Okay, I will increase the voltage. Before I increase the voltage, I will connect the power. I forgot to connect the power. Yes, so the power was connected. Great. So we can see the current right here, milliampere, and we can see the volt here in volts. Hopefully that's clear. What I will do right now, I will make this closer and closer for you, like this. So I will start changing the voltage. So let's have here maybe 0.5. Try to do our best to have 0.5 volt. So we have 0.5 volt and 4.39 milliampere. Great. Let's add now another point. So let's have 1 volt right here. Have it approximately. It is hard to have it exactly 1 volt, so 1.16 is enough. So 1.163 volt, and the current is 10.02 milliampere. Let's add another point. Let's move to 1.5. Do our best to have exactly 1.5. Yeah, so we have 1.508, 1.508 volt. Let's see the current. The current is 13.02 milliampere. Let's add another point, so 4 points I believe are enough. Let's do 2 volt. Great, so we have 2.176 volt, and the current here is 18.8 milliampere. That's great, guys. We are done with collecting the data for resistance number 1. Now I will move to resistance number 2. Let's do that. So to do that, we need to disconnect the power supply, make the voltage 0, and then remove this resistance right here and have the other resistance right here. Just to remind you guys, the goal from this experiment, which is Ohm's law, is to apply Ohm's law and figure out the values of some resistors. This is resistance number 2. Let's try to do that. Do the same steps. So I will choose 0. Before that, I need to connect the power supply, of course. So now I will have the voltage to be 0.5, around 0.5. Yes. It is hard to have it exactly 0.5, but we will do our best. So the voltage 0.526, current is 3.55 milliampere. Increase it to 1 volt. So now we have 1.016 volt. The current is 6.87 milliampere. Now I will increase it to be 1.5 volt. Yes, so now we have around 1.5 volt. So 1.522 volt. The current is 10.3 milliampere. I will increase it now to be 2 volt. Okay, so we have 2.109 volt, and the current is 14.27. So now we are done with this resistance. We collected 4 data points. Do that, guys. You too need to collect those 4 data points. I'll write them down. So what I will do, I will have the voltage to be 0 again. Remove this resistance right here and find another resistance. So I will do that. Yes, so this is another resistance. We will use it. Just connect it right here, as you can see, guys. Okay, and then do the same steps. So I will have the voltage to be 0.5. I will increase it to be 0.5 and see the current. So the voltage right here is 0.543. It is fine to have different values, not exactly 0.5, so that's totally fine, because it is really hard to use this knob to control the voltage. So you have 0.541 volt, and the current here is 2.48 milliampere. 2.48 milliampere. Now I will continue to increase the voltage to have 1 volt right here. Exactly. So here we have 1 volt. The current is 4.65 milliampere. So now 1.017 volt. And we have 4.67 milliampere. Move to 1.5. Okay, so here I believe approximately we have 1.5. I will do my best to have it exactly. Yeah, so 1.548 volt. The current is 7.08 milliampere. So that's great, guys. This is data point number 3. I will do data point number 4. So we'll have 2 volt now. So around 2 volt. So here we have around 2 volt, and you can see that the current here is 9.96 milliampere. So 2.176 volt and 9.94 milliampere. Great. So right now, guys, we collected the data from Ohm's experiment, and we did that for 3 different resistors. Now, guys, we will try to apply the plot that I showed you to figure out the values of these resistors. Let's go ahead and apply this and see what are those values. This is part 1 from today's experiment. So I will close the power supply, disconnect it, and then close the voltmeter and close the ammeter, and then turn off the voltmeter and then turn off the ammeter and then turn off the power supply. Remove the plug, and we are done with part number 1. Thank you, guys. Okay, so this is part number 2, guys, and in part number 2 we will try to evaluate the equivalent resistance for 3 resistors, 1, 2, 3, connected in series, as you can see. So we need to get or evaluate the equivalent resistance. So what we will do, we will use Ohm's law, do the same thing, measure the voltage across those resistors, and measure the current that flow in this circuit. And then plot the voltage versus the current to get the equivalent resistance. Just do the same thing, guys. So let's get started. Connect the circuit, as you can see. Turn on the voltmeter and turn on the ammeter, and then start the power supply. So we will have 4 data points. I will adjust the voltage here to be 0.5, around 0.5. So let's move. Yes, so we have 0.511 volt, and here we have 1.05 milliampere, and then move to 1 volt here. So here we have 1.021 volt, and here we have 2.1 milliampere, and then move here to be 1.5, around 1.5. Yep, so here we have 1.511 volt, and here we have 3.13 milliampere. So that's great. This is the third data point. And now let's move to 2 volt. Oops. Adjust it to be 2 volt. Yes, here in the voltmeter you can see that we have 2.06 volt, and the ammeter here we have 4.25. Yeah, this number is fluctuating, so you can have the middle number, so you can choose like 4.26 milliampere. Great, so now you have all of the data that you need to figure out the equivalent resistance for those resistors that are connected in series. So that's great, guys. And then you need to compare it with the theoretical value. So the theoretical value can be calculated from the law of adding resistors that are connected in series. Yeah, and that's it. So what we need to do, we need to turn on the power supply. Sorry, turn off the power supply, and then turn off the voltmeter, and then turn off the ammeter. So this is the end of part number 2. Okay. Okay, this is part number 3 of today's experiment. You can see, guys, that we connected those resistors in parallel now. They are in parallel. I will connect them to the circuit as we did before, and then apply Ohm's law to figure out the equivalent resistance for this group of resistors. Of course, they are connected in parallel. Yeah, and we will use Ohm's law to figure out that experimentally, of course. So let's get started. So I will connect the circuit, turn on the voltmeter, and turn on the ammeter. Turn on the power supply. Okay, and then start to collect the data. Do the same steps, guys. I will adjust the voltage here to be 5. So the current would be huge. So what I will do, guys, I think I will move with very small steps here. So let's do, for example, 0.288 volt. 0.288 volt. You can see that the current that flows in the circuit is 5.74 milliampere. I will now increase the current to be 0.4 volt. And you can see that the current is 9.25 milliampere. And then increase the voltage here to be 0.8, around 0.8. Oops. Should be around 0.8. You can see the current here is 17.61 milliampere. 0.61 milliampere. And then I will increase the voltage to be 1.12 volt. And you can see that the current here is 22.37 milliampere. Yeah, So this is the whole data that you need to figure out the equivalent resistance for those three resistors that are connected in parallel. Okay, so this is the end of this part and the end of the experiment in general. So I will decrease the voltage and turn off the power supply, turn off the voltmeter, and turn off the ammeter, and then disconnect the whole circuit. Okay, yeah, so let's get started, guys. You can start plotting voltage versus current and figure out the equivalent resistance for this configuration. Thank you.